Hello again. In the previous episode, we began to work of improving the jumping mechanics. And in this episode, we will finish it. Let's start by opening the player script. First of all, we will create a new Boolean variable. Write public bool on ground. We will use this variable together with hit ground to detect when the player is really standing on the ground. Then, let's get to the bottom of our script. Here we will write a function that deals with collisions. So, write void on collision state 2D, parenthesis, collision 2D, other and curly brackets. This function detects collisions between colliders that are not set as triggers. Note that this function is similar to onTrigger enter 2D, which detects collisions between trigger colliders. OnTrigger and onCollision functions have three variations: enter, stay, and exit. Enter is activated once when the collision happens. Stay is active as long as the two colliders touch each other, and exit is activated once when the collision ends. Also, pay attention that the type of the parameter is different between these two functions. OnTrigger enter 2D uses collider 2D, and onCollision state 2D uses collision 2D. Now, inside of this onCollision state, we need to write an if statement which checks if the game object that hit the player is on the ground layer and if hit ground is true. Write if other.gameObject.layer 2 equals to marks layer mask dot name to layer parenthesis ground in double quotes 2 ampersands and hit ground. Then, inside of the curly brackets, write on ground equals to true. It is important to include hit ground as a second condition. It ensures that on ground will be set to true only when the player stands on the ground. Otherwise, on ground would be activated in cases such as the player hitting the wall while jumping, and we don't want that. Next, head to fixed update and locate the if statement for jumping. Inside of it, write onCround equals to false. Then, on the if statement above, where we command the player to stop, replace hit ground with onCround as a condition. This enables the player to fall all the way to the ground normally without slowing down when hit ground gets activated. Before we test this in Unity, let's write one if statement at the bottom of fixed update. Outside of canControl if statement, write if on ground 2 ampersands and level finished. And inside of the if statement, write anim.setBool falling false. Because canControl will be set to false when we reach the goal, the player will get stuck on falling animation if he lands on the trigger area from the air. This line will make sure that the falling animation stops after the player hits the ground when level is finished. Alright, let's save the script and test. Great! Now the player falls on ground properly. However, if we move down on the slope, the falling is still quite clumsy in some cases. This is because the on-ground doesn't switch off. That can be fixed easily. We see that hit ground gets switched off even with the smallest movement. So we can just write an if statement that switches on ground to false when hit ground is false. We will also use the same if statement to deal with the hanging from the wall problem. Before we get back to coding, let's create a new folder in the project view. Name it to Physics Materials. Next, we will create 2 physics materials there. Right-click on the folder and select Create Physics Material 2D. Name it to Sticky. Change the friction to 1. Then duplicate the physics material and rename it to Slippery. Change its friction to 0. A physics material can be added to a rigid body or a collider, and it affects to the bounciness and friction of the game object. We will switch the material from code depending on the situation. When the player is on the ground, the material will be set to sticky, and when he is in the air, it will be set to slippery to prevent the possibility of hanging from the wall. Let's get back to the script. We need to write 2 variables for these 2 materials. Write public physics material 2D slippery and under it, public physics material 2D sticky. And then in start function, we will declare that the current material is the sticky one. Write rb.sharedMaterial equals to sticky. Next, head to Fixed Update. Above the can control if statement, write if hit ground and curly brackets. Then inside the brackets, write rb.sharedMaterial equals to sticky. After that, under the if statement, write else and curly brackets. And inside of the brackets, write rb.sharedMaterial equals to slippery. Here we will also set onGround to false, so write onGround equals to false. Let's save the script and return to Unity. Before testing, we need to assign the physics materials to the variable slots. When you're done, apply the changes to the prefab. Then, activate play mode. Wonderful! It works! Landing on the slope is smooth and we can't hang from the wall anymore. However, there is still one little thing to improve. When we climb up the slope and stop moving at the same time we reach the top, the player lands very slowly. This happens because the player doesn't fly high enough from the ground. As a result, the line keeps hitting the ground during the whole process. Therefore, hit ground and on ground stay true. And even though our code keeps setting the velocity to 0, the player slowly falls down because of gravity. Let's get back to the script to solve this. We need to create a new variable first. Write public pool on slope. Then set it to false in start function. Next, on update function, we will use Raycast 2D to detect the angle of the ground below the player. Raycast is quite similar to Linecast. The main difference is that instead of being defined between 2 points, it is given a starting point, a direction, and length. We will cast this ray into the same direction as the line. Under hit ground, write Raycast hit 2D slope hit equals to physics 2D dot raycast and parentheses. Inside of the parentheses, we need to define the starting point, direction, length, and a possible layer mask. Write transform dot position, comma, vector2 dot down, comma, 1.4f, comma, ground mask. This will cast the ray straight down from the player's coordinates and only detect the colliders on the ground layer. Next, we will calculate the angle of the ground below the player. Write if slope hit. We will store the angle in a variable of type float. Write slope angle equals to vector2 dot angle parenthesis. Now in the parentheses, we need to define two vector2 values. Unity will then calculate the angle between them. First, we need the angle of the ground. How then do we get it? This requires a bit of mathematical understanding. We want to know the direction of the normal vector at the point where the ray hits the ground. Normal vector is perpendicular to the surface, in other words, in a 90-degree angle towards it. We will get the desired information by simply writing slope hit dot normal. Next, it's time for the second vector2 value. To make the interpretation of the calculated values easier, we will use a vector that has the same angle with flat ground. Write vector2 dot right. This is the same direction with x-axis. To see the result of our calculation in the console, write print slope angle. Alright, let's test this. Remember to save the script. Before testing, we need to modify the level a bit. Duplicate the empty game object, which has the slope pieces inside of it. Then snap it on the right end of the ground platform. While the empty game object is selected, change the scale on x-axis to -1. Don't worry about how it looks like at the moment. You can improve it later. Now we just want to test how our code behaves in all of the possible cases. When we activate the play mode and walk around, we can see that the angle is updated correctly. On flat ground, it is 90 degrees, and on slopes around 45 or 135 degrees. The reason why the slope angles are not exactly 45 or 135 is that we have set the shape of the polygon collider by hand, and thus it's not so accurate. But that's not a problem for us. If you are wondering why the angle of the flat ground is 90 degrees, it is because the normal vector is pointing straight up from the ground. This is not a problem for us either. Great, let's get back to code. You can comment out the print command as we don't need it anymore. Next, it is time to create some if statements that check if the player is on a slope or not. The asset package that Nitomani provided includes only one type of slope, which we already have in our scene. Therefore, the angle of the slope will always be around 45 or 135 degrees. Also, the angle of the flat ground was 90 degrees, and a vertical wall would be 0. So, as long as the angle is not 0 or 90 degrees, the player is on a slope. Inside of the slope hit if statement, write if slope angle less than sign 75f, two vertical lines, slope angle greater than sign 115f. Instead of setting the values very close to 90, for example to 89 and 91, it is safer to leave some extra space between them. We can do this because we don't have many different kinds of slopes. If the situation changes, these values are easy to adjust according to the need. Next, inside of this if statement, write onSlope equals to true. When the angle is smaller than 75 or greater than 115 degrees, we are on a slope. Okay, then we will create another if statement. Write else if slope angle, two equality signs, 0f, two vertical lines, parenthesis, and inside of them, slope angle greater than sign 75f, two ampersands, slope angle less than sign 115f. Then set the on slope to false. When the angle is 0 or between 75 and 115 degrees, we are not on a slope. Let's save the script and test it. When we walk around, we can see that the on-slope boolean gets switched on and off as it should be. Only if we jump from a slope it stays on. This is easy to fix. In the if statement for jumping, write on slope equals to false. Alright, now we can finally fix the problem of slow falling. We need to write an if statement that checks if the player is moving down when on ground is active but on slope is not. So, above can control if statement, write if on ground, two ampersands, exclamation mark, on slope, two ampersands, rb.velocity.y, less than sign, and 0f. Then, inside of curly brackets, we simply need to set on ground to false. Save the script and return to Unity. Perfect! Now the player lands correctly. Amazing work! Now the jumping mechanics are sufficient. The player can no longer hang from vertical walls, and jumping and landing are more credible as well. Also, when on a slope, the mushroom doesn't behave like a ski jumper anymore. In the next episode, we will add some challenge to the game by creating an enemy that is able to move. See you there!